Bismillah ar-Rahman ar-Rahim. Welcome to Lady Khadija radiallahu anha. May God be pleased with her online college. Live lesson A-Level Maths Year 2, Trig Ratios, Exact Values. If you're following through the book, then it's Chapter 5, Example 6. Okay, Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Today's topic is trig ratios and some exact values. So let me give you a couple that you might be familiar with. Sine 30 degrees is equal to 0.5 or a half. Now that you're familiar with or getting familiar with radians, you need to know this in radians as well. So 30 degrees is the same as pi over 6. So we can say that sine of pi over 6 is equal to 0.5 as well, which is a half. That's one of the easier ones. Another easy one to remember is tan of 45 degrees is equal to 1. What would that be in radians? So that would be tan, and this time, remember pi is 180 degrees, so that's pi over 4. So pi over 4 would be equal to 1. So they're the two basic ones. The rest of them aren't so basic. You do have to learn them. So I've got a page here that you have to go through yourself and just learn the exact values. By exact values, it means you have to memorize it in the square root form. So you've got a half is the easy one, but the other ones have got square roots in them, like root 3 over 2, root 2 over 2. So you have to measure them all. You have to know them all, memorize them all. The next thing you want to take a look at is some very simple identities here. So let's just take a closer look at some of them. So here we're saying that if you take an angle, an acute angle, and you do pi take away that angle, then the sine of that is the same as the sine of just the angle on its own. So if we take, for example, 30 degrees, then 180 take away 30 degrees, which is 150 degrees, would be the same as sine of 30 degrees. If we take it in radians, then pi take away pi over 6 would be equal to sine of pi over 6. So let me just write that example for you. So if we take theta to be pi over 6, then I can write sine of pi take away pi over 6, in other words 30 degrees, would be equal to just the sine, the normal sine of your normal 30 degrees, or in radians pi over 6. The other ones to memorize are sine of pi plus theta is equal to minus sine of theta, sine of 2 pi take away theta is equal to minus sine theta, and then some cosine ones, and then some tan ones. You'll have to memorize them, and then the main thing is, can you try and use them? So I'll have them here and we can refer to them in a second. Let's go through the first example. So the first example is to find the exact value cosine 4 pi over 3. So notice we've got it's cosine, not sine, and it's 4 pi over 3. So you want to look at that 4 pi over 3, and then you want to compare it to one of the easy ones that you've memorized or you will be memorizing, and think, how can I take 4 pi over 3? How can I slightly rearrange that or manipulate that so that it looks similar to one of the ones that I know? Pi over 6, pi over 3, pi over 4. Really, pi over 6 and pi over 4 don't look anything like 4 pi over 3, but cos of pi over 3 might help. So let's take a look at that one. And then what we notice is that how can I change 4 pi over 3 to look a little bit like pi over 3? It's not going to be exact. You can split 4 pi over 3. Remember that 4/3 is really 3/3 plus plus another third. So 4/3 is really 3/3 plus another third. And 3/3 is just a whole. That's just one complete whole unit. So similarly, if I was to do that here, then I would say the cosine of 4 pi over 3 is really 3/3 pi plus 1/3 more, 1/3 of pi. And 3/3 is really a whole, so I can delete the 3/3. Then I'm left just with pi. So the cosine of pi plus 1/3 of pi. Okay, now take a look at, so we've got it in terms of pi over 3. That's your pi over 3. But we've got an extra pi that's getting in the way. But that's okay because we've got some identities that we can call upon. So we've got cosine of pi and then plus an angle. So let's take a look at anything similar to that. We're looking at the cosine ones. That's these three, and we want cosine of pi plus an angle. So that's this one. So let's take that. And now how are we going to use that? We've got the pi plus the angle is equal to minus cosine of that angle. So we can rewrite this as that the cosine of pi plus an angle is equal to minus the cosine of the angle that you're adding. So it's just pi over 3 minus cosine of pi over 3. And pi over 3, we picked that for a reason because it's one of the easier ones to memorize and learn. It's just equal to a half. So the cosine of pi over 3 is equal to a half. So that means I've got minus a half because this bit is equal to a half, so minus a half. Okay, let's just quickly review that. So first step was to take 4 pi, the angle that you're given in the question, try to look at the trig ratio you're using, which is cosine, and try and think what kind of, how can I split that so that at least part of it is similar to the ones that I know. And here we were aiming for pi over 3 because we were most confident that we could get this to split to at least look something like pi over 3. So you just remember that 4/3 is really 3/3 plus a third. So then I can split 4 pi over 3 into 3/3 pi plus a third pi. So then I've got my pi over 3 appearing here. 3/3 pi is just a whole, so I can get rid of that. And then after that, we want to try and think, okay, what can I choose from the list that we had on the other page, which was this one, something that resembles that. So I've got cosine, and I've got pi plus an angle. So cosine and then pi plus an angle, and that tells me that all you need to do to get the answer to that pi plus an angle is you just do minus cosine of that angle. So that means pi plus pi over 3, the cosine of that will just be equal to minus the cosine of pi over 3. And pi over 3, cosine of pi over 3 is one that we memorized or you will be memorizing, and that's just minus a half. Okay, let's try another one, this time where the identities aren't really gonna